Hello viewers, today we will start training on Aspire. Right now you can see here that I have opened Aspire 951.4 in front of you, and in my other videos you will also be able to see its installation. You know that currently this software is very popular in the market, especially for CNC routers, and people are liking it a lot. The reason for this is that it is easy to operate. Its programming is very good and it offers quite a few excellent features. It also supports many other software, and so now we will work on its basic on a platform. On the basic platform, the beginner level. We'll adjust to it very well. Let's start. First of all, you can see this here. This is basically our working area. The screen is the working area, and here we have the pull-down menus, which include File, Gadgets, and Help. If we go to the Startup task, we can create a new file, open a file if you have worked on it before. You can access it from here, and you can create a new file from here. The open files that we have recently worked on will be available here. There are already some tutorials available which you can use as well. They have their own tutorials, and there is also a clip art library available here. These are its online resources available. So let's start by creating a new file. As soon as I create the file, you will see that within the job setup it tells you the job type, whether it's single-sided, double-sided, or for rotary work. I'm giving you a bit of an idea as we go along. We will continue to cover the rest of the things, God willing. Whenever you are creating any design, normally, if you need to do cutting, which is referred to as 2D cutting, you should select single-sided. If you have a job that involves cavity work, or you want to give an impression on it, then you need to apply it on both sides, in and out, using double-sided. But normally 2D basic, this staying within the weight, we will now work on a single side. The size we have is for the X direction, for the Y direction, and not for the Z direction. We will need to discuss the units here. Both crepas are available here. If you want to work in inches, you can do so in inches, and if you want to work in millimeters, then you can do it in millimeters. Therefore, since we are discussing this region in Pakistan, it was noted here that the majority of our carpenters are more familiar with working in inches here. They mostly work in inches. It's not a big deal. You can work in both. If I share my personal experience with you, working in millimeters is good. It provides good accuracy. It's easier for you to evaluate. It's easy to take measurements done and manage them in detail, because it's a decimal system, which is the metric system. You can maintain its accuracy and precision by dividing 1 by 10, and then again by 10, and then again by 10. Here, I would like to mention that typically our sheet is 4 feet by 8 feet. It is approximately 4 feet by 10 feet. 4 feet. So the routers available in the market are generally made for 4 feet by 8 feet. So if I talk about 4 feet, the valves that we need to input in inches, I will input the value here in inches accordingly. On the other side, I have entered it as 96 inches. Now, thickness is a very important topic, and you should never make a mistake about it. We have a peculiar problem here that when we measure, the length and width are in inches, but when it comes to thickness, it is in millimeters. There are sheets of 10 millimeters, 12 millimeters, 15 millimeters, 16 millimeters, and then we also have sheets of 18 millimeters, and that's where we get confused. We have already put 48 by 96 inches on top, but when it comes to thickness, no, it is commonly referred to as 3/4 of an inch or a 6/100th sheet. So this is something you will have to check for yourself. Suppose I guide you a little here. If a material like this comes up, there is nothing to worry about. Open the calculator. As soon as you take the calculator, suppose you have a 10 millimeter sheet and you want to define its thickness in these terms. Then divide it by 25.4, so you will have 0.4. You can write it as 0.4, which you can enter here as its thickness. Similarly, if you have a sheet of RMM, generally people also call it half an inch. Actually today, half an inch is not complete, but you can also add it as half an inch. You will also do this with 25.4, which is our conversion unit, and this will give you the size of 0.47. So if I round it off, it becomes 0.5. But the purpose of telling you all this is that you can convert these values in this way and input them. If it comes to 3/4 of an inch, you will definitely write 0.75. If it comes to me in millimeters, you can do that too. So this is basically the method, and keep in mind that when we use inches here, you will have to select the remaining area in the same way. Like when you look at his design, you will see it in inches, and when you look at tools, you will see them in inches. So this is basically a method. Here we have the zero position, meaning how we have to take the zero position of the z-axis. To set the zero position of the z-axis, we have two options. One is the material surface, meaning you use the surface of what you are clamping as the zero reference. The second option is the machine bed, meaning you consider the bed on which you have placed the sheet as the zero. So the normal practice is to use the material surface. Moving forward, we have the XY datum position. The XY datum position is also a very important topic. Here, you can see it has indicated 5 points of a rectangle. This one, this one, this one, this one, and this one. If you look at the screen here, you can see all the positions. That is, when you start designing or want to start the program, what will be the home position of the tool on your machine? I would like to reiterate that the job you are clamping on the machine, the workpiece you are clamping on the machine, and the tool you are using with it, you will need to select for your job. And what should be the home position of the tool? Then go to the tool's home position. This is each person's own practice. Or it depends on how your design is. Or it depends on how your job is. It might be that the job you have set up is such that you cannot even give it a position. Place a piece here for it. You don't even want to bring the machine here. It might be that an entire Audi door is being made here, a panel is being made. So the RDP work has already been done here, or some pieces are protruding. So you want the machine not to come from there at all, you have to work here. So you set the home position for the machine here, which is also called the datum position. It might be that you have to do it here, so it varies from job to job. And with practice, these things will start to improve on their own as you physically stand by the machine and practice. So, let's move forward. The normal practice is here. Often what we do is when there's a small piece, we take its position in the middle. Meaning if, let's say, you have to work within a foot or two on, instead of managing the margins and other things on the sides of the design, which becomes a bit difficult, the best way is to cross it from here to here and from here to here, mark its center point and set your tool's home position at its center. Then, whatever designing is done, it will automatically leave equal margins on the sides. So you don't have to keep setting their margins yourself. This is also a good practice. So I will now set its position here. As soon as we move forward from here, Martha, yes. As soon as we proceed from here, we have marked the X datum position. We will continue from there. This is our molding resolution. It's not a very important matter, but you should have an understanding of it. This is its molding resolution. It's set to standard for fast trim software. It will slow down. If you increase the resolution further, then its sewing time and software will work slower. So what we usually keep in normal practice is set to standard. Look, we have all three options available here. You need to select based on your requirement. Here, we will slow down the fastest software 3 times. We will slow it down 7 times. What difference will it make by going to a very high page? The resolution of your modeling will basically go to high resolution. It will go to high resolution, and when you do it there, your software will become a bit slow. But the resolution of your job will start to look more beautiful. At this moment, we need fast software, so we will keep it on standard. Here is the color scheme. Whatever material you are using, you can use the color according to that material. If I want to work on wood, I will go to wood. Now, it automatically gives the color for wood here. What is inside the wood? In the middle is dark, in the middle is light, and you can take different colors from here. If you're working on if you're working on metal, you will find brass in it. It's light, dark, reflective, brass, bronze, golden. Similarly, if you want to work on stone, basically all these things you can work on within the software. You can pre-assign its color accordingly. Like this is in plastic, blue plastic, green. So basically, all these things are for its appearance. So I go into wood and make it medium dark. See here, you have seen that this is on appearance. And modeling resolution overall. This was our tab. This tab of job setup is now closed. I click OK on this. As soon as I click OK, now see the environment we have got. Let's take a look at this environment. We have File, Edit, Model, Toolpath, View, Gadget, and Help are available here in the pull-down menu. This drawing tab is currently open for us. We call this the drawing tab. Inside the drawing tab, there are 3 more tabs. That means it has a total of 4 tabs. First of all, there are the standard tools. Here you can import vector and import bitmap from new. Open, meaning you can import 2 things in it. One is vector, meaning line art, and the other is bitmap, meaning picture. Here is set job dimension and origin, the dialog we recently closed. Basically the same dialog comes back here. So let's come back here. You have the option for copy, paste, undo, and redo available here. Regarding creating a job, we have some tools available here. These are the file operation tools. These are the job vacancy tools. You can draw a circle, an ellipse, a rectangle, a polygon or saw, etc. Here you can draw a full line, draw an arc, and draw a spline, which is a curve. We have textures here, like the hatch you have seen in AutoCAD, and similarly it has this texture, but it is drawable, mappable. So here we have a form, because here it is not written as P, it is drawn. Draw means write. So what we do is only used for reading or for printing, but when we talk about drawing, that's why it is written as drawn. It draws because it traces and writes, which you can cut and edit. Here we have the draw text. Within the vector box, no more knowledge or knowledge. If you need to go in the form of a paragraph, this is edit text, but no bullshit. Spacing and kerning, meaning if you want to adjust the spaces of a text or align it on an arc and here we have convert kerning, meaning you can convert an object into kerning, any standard object, like here it has got the form Delhi, and you can convert it into a standard object. Similarly, here we have text on arc meaning here you can write any text on an arc. You can edit it from here, you can write from here. This is a very useful tool in trace bit to trace any bit. You can take dimensions of an object while staying in the code. So this was our create vectors. Let's move forward. Transform object, meaning for placement, etc. The first object is our move selected object to move any object left, right, or in any direction. There is scale object for scaling, to make it bigger or smaller, for rotating, for mirroring, and it's this object here. This is also a very important object in it. With this, you can see that help is coming along with it. With this object, you can shape anything. You can do it. You can give the design to scroll to body. We have an even more useful object than that, which is align. We can align different objects with reference to each other. This basically comes from the transform object to edit objects. If we want to edit any object, these are basically all the tools for it. There is a selection tool of node editing mode, meaning if you want to edit on any nodes. And this is the transform mode for moving, rotating, etc. As soon as you want to use this feature, you have to use this tool. Here we have the group on group tool available. Here is the measurement, like there is a tool for distance. So similarly, this tool also works. Or if I talk about the list in pieces, these are almost the closest features where you can measure distance, area, length, etc. And this is for weld, trim, or subtract. This is to save the overlapping area, and this is to trim in it, trim selected object. This is also an interactive trim. To trim a selected area or line, it trims a combination. Here is the vector validator. This vector validator is to check his drawing. Here, as we were talking, we have the field tool. We can use this tool for a stand, etc. We have the convert to curve or curve tool. This is to create a boundary. In this way, there is an open picture editor. This is for editing pictures to crop a picture in crop. This is for joining. This is also a joining tool, and it joins the nodes that are connected overall with a specific tolerance A, and it joins 2 points together by filling the space or gap with a straight line. It will fill the gap with a curve, and it will pull both joint nodes over each other and join them. In this way, there is an offset tool, array tool. It will copy its circular array or array. It will copy over a path, and this is its place production tool, meaning understand that when we work for cutting or production, this tool is used there. This tool is automatically aligned. This tool is used for doing this. We will practice it further. Basically, today's topic was to study the tools available in 2D. Here I will explain that these are modeling tools. When we work in 3D, we will use these tools. Clip arts are available, and we can place different clip arts here. And from here, we manage their layers. Today's topic is to study 2D tools, 2D drawing, and 2D tools. Here you can see the 2D view, and alongside you will be able to see the 3D view. This is the setup for its layers, a complete panel for layers. Moving forward, we have some options related to the view, such as turning geometry snapping on or off, turning smart snap on or off, panning, and 2D zooming. This is for driving with the mouse, and the active zoom will zoom to the drawing limit or to the selected window. This is for the tool path, and it will toggle the visibility of the tool path on or off. It will convert from wireframe to solid, and similarly, it will toggle the visibility of the material block. Here we have options to arrange views horizontally and vertically. You can see we have a tool path here. When we do its machining, we will need to use this tab. To toggle it, we have a toggle switch available. It will draw off and switch to the tool path. This was basically an introduction to Sprite 9.4, where you learned which tools are available and how we can use them, how to operate these tools, how we will create different drawings with them, how we will import various vectors, and how we will import different images and bitmaps. On top of all these tools, how will they use it? How will we create our required job on it? Inshallah, you will find all these things. In our next lectures, I hope that this information will be useful to you. The things I am telling you will definitely become a part of your professional life. Please remember me in your prayers. Please subscribe to our channel, like the videos on this, and be sure to share these videos with your friends and acquaintances. Peace be upon you and the mercy of Allah.